This video I am going to explain resonance and types of conjugative systems and resonance energy. So in the first one, what is resonance? So resonance is the phenomenon of delocalization. The phenomenon of delocalization of pi electrons and non-bonding electron. Pi electrons and non-bonding electrons. Is said to be resonance. What is resonance? The phenomenon of delocalization of pi electrons and non-bonding electrons in conjugative system. Conjugative system, molecule should be conjugated one. In conjugated system or conjugated molecule is known as resonance. Delocalization of n electrons, non-bonding electron, pi electrons of which molecule? Conjugated molecule. Molecule should be conjugated. That is called as resonance. What is resonance? Resonance is delocalization of pi electrons and non-bonding electron in conjugated molecule is known as resonance. Example, benzene. For benzene, there are 3 double bonds between 6 carbon atoms of cyclic system. Due to resonance here, resonance is like this. This pi bond shift here, this pi bond shift here, this pi bond shift here. So that gives another structure, that is here double bond, here double bond, here double bond. That always in delocalization like this. So these two are called resonance forms. Resonance forms or resonance structures. Resonance forms or resonance structures. Resonance structures. So its resonance hybrid is like this. Double bonds in continuous delocalization. This is what resonance hybrid. Resonance hybrid. That means I can write here a point. Resonance can be expressed through some resonating forms. Resonance can be expressed through some resonating or resonance structures. Resonance structures. What is resonance? Resonance is delocalization. This double bond is not localized between these two. This double bond comes here. That means delocalizing. So pi electrons are delocalizing here. Here there is no non-bonding electron, only pi electrons delocalization in benzene. So delocalization of pi electrons in conjugative system. What is conjugative system? Alternate single double bonds. So I will explain different types of conjugative systems. Resonance can be expressed in some resonating structures. Resonating structures are canonical forms. They are what? They are hypothetical one. Resonance structures are hypothetical one. Resonance structures are hypothetical, imaginary. They do not have real existence. Hypothetical means imaginary. They cannot be isolated. Okay, so if you label one carbon, instead of C12, C14 is taken, and here some C14 is taken. This double bond not always between these two. You cannot take a benzene. Here only these two carbons having double bond. Sometimes these two carbons may have single bond also. Okay, so you cannot isolate this one. Even you cannot isolate single bond between two probe carbons. These two carbons, single bond is not present, double bond is not present. These two cannot be isolated. So there is a partial double and single bond character always. That means double bond is delocalizing, continuously delocalizing here. Resonance structures are hypothetical. They are imaginary. They cannot be isolated. Okay, resonance can be expressed through some resonance forms, but these resonance forms do not have real existence. Okay, so this is resonance hybrid. Resonance hybrid gives how delocalization takes place like this. Okay, here double bonds are delocalized, 3 double bonds are delocalized between 6 carbon atoms continuously. Okay, take this one. Next, see types of conjugative systems. Resonance is possible only in conjugative system. Types of conjugative systems. Types of conjugated systems. Types of conjugative systems. In that first one, pi and positive charge. This positive charge due to vacant orbital. So positive charge in general organic molecule, positive charge acquired due to two phenomena. By loss of electron pair, they have vacant orbital. By gain of proton also they acquire positive charge. Here positive charge must be due to loss of electron pair. Due to loss of electron pair, vacant orbital is existing. But whenever, for example, in CH4, whenever CH4 molecule loses hydride ion, hydrogen along with electron, here it has vacant p orbital. So like this. This is positive. But if you see in NH3 lone pair, if it accepts proton, what happens? This nitrogen become positive. Not talking about this positive, talking about above positive. Positive charge due to vacant orbital, not due to gain of proton. Okay, here positive charge due to vacant orbital. Pi bond and positive charge conjugation. Pi bond and positive charge conjugation. Conjugation means alternate. Conjugate positions means alternate position. Here pi and positive charges present alternate position. Pi bond and positive charge present at alternative position. Example, CH2 double bond CH2 plus. Here this is pi bond sigma positive charge. alternate position, pi, sigma and positive charge, alternate position. Here between these two, one sigma is present, alternate position, or otherwise, or another example, CH2 double bond CH, single bond CH, double bond CH2 positive. So here what? Pi bond, single bond, pi bond, single bond, positive charge, like this. Okay, one example is enough. So whenever pi bond, pi and positive charge are conjugated, pi bond move towards positive charge, pi bond move towards positive charge. There are some positive charge. There are some points which need to understand, which need to remember to understand resonance concept perfectly. So that means pi bond and alternate means sigma, again here positive charge, alternate system. So here positive charge move towards, how delocalization takes place? Pi bond move towards positive charge, pi bond move towards positive. In this way delocalization takes place. In conjugative system, here it become double bond. See here, so these two electron, one electron belongs to this carbon, second electron belongs to second carbon. Here movement of two electron takes place. This carbon along with this electron become minus. So these two electrons shifted here for the formation of new bond. Here this carbon orbital with two electron and this carbon orbital vacant, overlapping takes place, vacant. So this second carbon, this is third carbon. Second carbon orbital along with two electron moving here. This carbon vacant orbital overlapping takes place and formation of sigma bond, pi bond. Pi bond is formed, covalent bond, covalent and pi bond. So due to here, before which type of overlapping takes place? Pi overlapping takes place like this. Okay. So here this orbital, second carbon orbital completely moving towards the third one, this become vacant. Its p orbital become vacant. So try to understand concept. How will a sigma bond is formed first? So first carbon atom sigma, second carbon atom sigma, overlapping takes place. First sigma bond, first carbon atom p orbital, second carbon atom p orbital. Otherwise first carbon sp2 orbital, second carbon sp2 orbital, not p orbital. First carbon sp2 hybrid orbital, second carbon sp2 hybrid orbital overlap. Then first carbon p orbital, second carbon p orbital overlap, pi bond formation takes place. The pi bond has two electrons. Next, this carbon, third carbon, second carbon p orbital overlapping takes place like this, two electron. Here this third carbon p orbital has vacant p orbital. This is, these two electrons are moved towards this one, then this become positive. This carbon become positive. So here movement of two electron, these two electrons. Thus this carbon getting what? Positive charge. That carbon getting positive charge. This is the delocalization of pi electrons. Which type of conjugative system? Pi, sigma, positive. Pi and positive charge are in conjugation. Conjugation means alternate. The term conjugation means, conjugate position means alternate positions. Okay. Next, if you see, For this one, pi bond shift here like this, this become positive. These two are what? Resonance forms. Resonance forms. For this one, these two are what? Resonance forms. Resonance forms. So what is the resonance hybrid for them? Resonance hybrid is CH2. Sometimes double bond appear here. Sometimes double bond appear here. Sometimes positive charge here, partial positive. Sometimes positive charge here, not complete. Partial positive, positive. This is what? Resonance hybrid. Resonance hybrid. Resonance hybrid explain all properties. But any one of resonance structure cannot explain all the properties of organic molecule. One resonating structure cannot explain all the properties of this molecule. Resonance hybrid can do. So for this resonance hybrid is, here double bond sometimes appear here between 1-2 carbon, sometimes appear between 2-3 carbon. So sometimes positive charge appear at third carbon, sometimes positive charge appear at first carbon. Resonance hybrid. This is what? Resonance hybrid. Resonance hybrid. Okay. Next. Next example, if we see for this, so delocalization of pi electron towards positive charge. Remember this point. Here double bond. Here this is positive. Okay. So for this, what is the resonance hybrid? Double bond delocalizing between 2 pi electron delocalizing between 3 carbon atom. 2 pi electrons delocalizing between 3 carbon atoms. Sometimes this carbon become positive, sometimes this carbon become positive. Okay. These two are resonating forms. This is resonance hybrid. Delocalization of this pi bond takes place here. It gives, this is pi bond formation and this carbon become positive here. Next, delocalization of this bond takes place here. Next, here this carbon become positive, here formation of a new bond, formation of pi bond there. So these are what? Resonance structures. Resonance structures. What is its resonance form? Resonance form with here sometimes positive, sorry, double bond, sometimes single bond, here double bond, single bond, double bond, single bond. Okay, sometimes here may be positive like this, sometimes here may be positive, sometimes here may be positive. Positive charge is 1/3, 1/3, 1/3, 1/2, 1/2, 2 times 1/2, 1/2. So this is what? Resonance hybrid. Resonance hybrid. Resonance hybrid. Next, take one more. Here positive charge, a double bond, here double bond, here double bond. So always whenever pi bond and positive charge in conjugation, positive sigma pi conjugation, then pi bond move towards positive. Remember that point. So here what? Here formation of a double bond due to overlap of this orbital with that sp2 carbon. This sp2 carbon, that first and second. Then this carbon become positive. Here double bonds are same. Now shift of this bond towards positive. Pi bond always shift towards positive. Then it gives, here we are getting positive charge, here double bond, a double bond, here already double bond. Now shift of this bond, always pi bond shift towards positive charge, like this. Whenever pi and positive charge in combination, so conjugative system, conjugative or not, yes, double bond, single bond, positive, conjugative. Whenever those are conjugative, pi bond move towards positive charge, like this. Okay, now shift off this electron, it gives what? Here double bond, here double bond, here double bond. Then this electron move towards, movement of this electron, not like that, movement of pi electron towards positive. Okay, then this carbon become CH2 plus. So if you compare 1 with 5, here how many resonating forms? 1, 2, 3, 4, 5. These 5 are resonating forms. So among these 5, between 1 and 5, what is the difference? 1 and 5 are same. 1 and 5 are same, but delocalization of pi bond takes place. So here 1,2 carbon single bond. Here 1,2 carbon, what? 1,2 carbon has double bond. Thus delocalization takes place. What is its resonance form? In the resonance form, here double bond, 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 continuity. So we write like this. Here may be double bond, CH2. Sometimes a positive charge appear here, sometimes positive charge appear here, sometimes at this position positive charge, sometimes at this position positive charge, sometimes at this position positive charge. Resonance hybrid. Okay, right. Here I want to say one point, that is resonance energy. What is resonance energy? Resonance energy. What is resonance energy? The energy difference between the energy difference between more stable mean less energetic. More stable mean less energetic resonance form or resonance structure. The energy difference between more stable or less energetic resonance form and energy of actual molecule is said to be resonance energy. What is the resonance energy? The energy difference between, so among these five are resonating forms, in which one is resonating forms? Resonance structures or resonance forms. This resonance form, in which you have to select least energetic form, more stable form energy and actual molecule. Practical, this is theoretical. So resonance energy calculated theoretically. Resonance energy calculated. Resonance energy is energy difference. So energy of resonance forms calculated theoretically, or otherwise what do you say, by heat of hydrogenation method, calculated theoretically by heat of hydrogenation or heat of combustion. Okay, from their heat of hydrogenation calculation, not required for us here, not required for JEE Mains and NEET syllabus, just information I am giving. So most stable form energy and actual molecule energy, the difference between them is called resonance energy. So as resonance energy increases, as resonance energy of compound increases, as resonance energy of compound increases, as resonance energy of compound is more, its stability is more. Just information, resonance energy is, so for one molecule resonance energy is given means its least energetic form energy and actual structure energy, actual form energy, that gap is more. More energy gap means more stable. More energy gap means that energy gap is called one more energy, that is resonance energy. The least energetic form energy, least energetic resonance form energy and actual molecule energy difference is called resonance energy. Resonance energy is just energy difference. If more is the energy difference, more will be the stability of the molecule. Okay, in general we say when energy increases, stability decreases. But here resonance energy is not direct energy. It is difference between two different forms, different between two hypothetical one, this one, and actual molecule. Resonance molecule and actual molecule, that energy difference. So I am telling only one thing, that if energy of a molecule is greater, its stability is less. But here resonance energy is not direct energy, it is difference in energy. As difference in energy, as resonance energy increases, stability of molecule decreases. Remember that point. Okay. Next, I have explained only one type of conjugative system, that is pi sigma positive charge conjugation. In the similar way, we have pi and negative charge. Conjugative systems. Pi and negative charge conjugative systems. Pi and negative charge conjugative systems. Second type of conjugative system, pi and negative charge or lone pair electrons conjugated system. See, this is second type. So here, whenever pi and a negative charge are in conjugation, here pi bond, not pi bond, negative charge or lone pair electrons move towards pi bond, move towards pi bond, See, if conjugation is like this, pi, okay, this is pi bond, alternate mean 1 sigma, between those two 1 sigma. Then here some lone pair or negative charge, like this. Then what happen? This negative charge move towards pi bond. So then this bond move towards this carbon. Like this, delocalization takes place in this type of conjugative system. Whenever negative charge pi bond are in conjugation, delocalization takes place in such a way that negative charge or lone pair electron move towards pi bond. Delocalization takes place in such a way. Here delocalization takes place in such a way, negative or lone pair electron move towards pi bond. So this becomes single bond, here we get double bond. Okay, so these two are what? Resonance forms or resonance structures. The resonance hybrid is CH2 single bond CH2, here sometimes double bond, here sometimes double bond, this carbon partial negative, this carbon partial negative charges, that is the resonance hybrid. Double bond always delocalizing between 3 carbon atom. Resonance hybrid, only 2 pi electrons delocalized between 3 carbon atom, like that. Or we can say another example, we can say many examples, but I am writing only few, like this. Here also what? Negative charge and pi bond in conjugation. Pi, negative charge, sigma, this is not. Right here, conjugation. Negative charge, sigma, pi bond. Conjugation mean alternative position. So pi, sigma, lone pair. So in this case, what happened? Charge move like this. Negative charge move towards pi bond. Then it gives a structure like this. Here, shift of this electron takes place, and this become a new bond, double bond here. Okay, these two are resonance forms. Resonance hybrid is here. Sometimes it become double bond, sometimes it become double bond. Okay, sometimes a negative charge appear here, sometimes a negative charge appear here. So this is the resonance hybrid. These two are what? Resonance structures. Okay. So in this case, whenever pi and lone pair, or whenever pi and negative charge are in conjugation. Next, taking this one, pi bond CH and lone pair. Just I want to show how lone pair move towards. Here lone pair move towards pi bond, this comes here. If you write this one, so this carbon getting 2 electron, that become negative. Okay, here CH, here already bond is there, new bond here. This carbon vacant orbital, nitrogen completely filled orbital, sp3 orbital. This carbon sp2 vacant orbital, this nitrogen completely filled sp3 orbital, overlapping takes place. Then this nitrogen become positive. Okay, while writing resonance forms, we need to remember. In resonance, in resonance, there is delocalization of only electrons, not atoms. Therefore atoms positions must not change. Here delocalization of only electron, not atom. Atoms are localized, they are stable, but only electrons are delocalizing. That means atoms do not change. That is first point we need to remember. Second point, the total charge on all resonating forms, all resonance forms, the total charge on all resonance forms must be equal. The total charge on all resonance forms must be equal. See here, what is total charge? 0. Here plus and minus 0. Total charge 0, total charge 0. Total charge. What is total charge? 0. Here what is total charge? Here also 0. Total charge is 0. Total charge must be 0. If here is minus 1, here also minus 1, like that. Okay, take this one. Next type of conjugative system, pi and free radical conjugation. Different type of conjugative systems we are discussing. 2 conjugative systems completed: pi and positive charge conjugation, pi and negative charge combination. 2 types of combinations, 2 types of conjugative systems. In one conjugative system, pi bond and positive charge are conjugated. In second type of conjugative system, pi bond and negative charge are conjugated. Now third one I am going to discuss, that is pi bond and free radical. Conjugative system, pi bond and free radical conjugative system. Pi bond and free radical conjugated system. See here. Here delocalization takes place. Here delocalization takes place in such a way that pi bond undergo homolytic bond cleavage. Pi bond undergo homolytic bond cleavage. That means, see here, double bond, single bond and free radical. Conjugative or not? Yes, conjugative. So pi bond, sigma bond, free radical, conjugative. Here in this case what happened? This pi bond undergo homolytic cleavage. Due to homolytic cleavage, free radical. Due to homolytic cleavage, free radical and free radical. Now this free radical with this carbon form a new bond here. Here free radical remains. Like that. Pi bond undergo homolytic bond cleavage here. So this is resonance. And fourth one, pi bond and pi bond, pi bond and pi bond conjugated system, pi bond and pi bond conjugated system, pi bond and pi bond conjugated system. See here, like this. One pi bond move towards other pi bond. One pi bond move towards other pi bond. This one move towards this one move towards this one. Electron movement towards more electronegative atom. Electron movement towards more electronegative atoms. Electron movement towards oxygen more electronegative than carbon, like this. So it gives here this carbon, these two electrons are moving, complete pi bond shift move towards, then this carbon become positive, and this becomes single bond. Here a new bond, double bond. Here the oxygen taking complete electron, so oxygen become oxygen taking complete pi electron. So total charge here, what is total charge? 0. Here total charge is 0. Total charge is 0. Total charge is 0. Okay, like this. So this is another type of conjugative system. Just I am telling about different types of conjugative system in which resonance how will takes place. Delocalization of pi electron and a non-bonding electron in conjugative system is called as resonance. Resonance, what is the criteria for resonance? Conjugative system is criteria. There must be conjugative system. How many types of conjugative system? There are different types of conjugative system. 4 are discussed here now. So one is pi sigma positive conjugative system, pi sigma negative charge conjugative system, pi sigma free radical conjugative system. Next pi bond, sigma bond, pi bond, pi bond, sigma bond, pi bond. So one pi bond is non-polar, other pi bond is polar. One pi bond is non-polar, other pi bond is polar. So this pi bond is non-polar. This pi bond is non-polar. Non-polar pi bond. Non-polar pi bond. Non-polar pi bond. And this is what? Polar pi bond. This is what? Polar pi bond. Polar pi bond. Polar pi bond. We can say like this. Electron movement takes place towards more electronegative atom, or non-polar pi bond. Non-polar pi bond. Non-polar pi bond move towards polar pi bond. Polar pi bond. What is polar pi bond? A pi bond is formed between two different electronegative atoms is polar pi bond. A pi bond formed between similar atoms is non-polar pi bond. Non-polar pi bond move towards polar pi bond, like this. Next, fifth type of conjugative system, that is lone pair and positive charge conjugative system. Lone pair and positive charge conjugative system. This resonance is very important concept to understand mesomeric effect and stability of organic molecule, stability of reaction intermediates, basicity of amines, and acidic basicity of aromatic amines, basicity of other amines also, basicity of amines, and acidic strength of carboxylic acid. Just like inductive effect. Inductive effect explains stability of reaction intermediates and stability of organic acid and basicity of acidity of organic acids and basicity of amines. Stability of reaction intermediates, acidity of organic acids, basicity of amines, could explain it by inductive effect. In the similar way, mesomeric effect also. Mesomeric effect also, our next class mesomeric effect. Your next type of conjugative system, that is I think fifth one. Fifth one is lone pair and positive charge. Lone pair and positive charge conjugated system. In this type of conjugated system, delocalization takes place. Delocalization takes place in such a way, that what lone pair move towards or negative charge, move towards positive charge, move towards lone pair or negative charge, lone pair or negative charge, move towards positive charge. Example, see here. Here carbon with positive charge, single bond CH, double bond NH2, like this. How? These two. Then your CH3 remains same, this become double bond and your nitrogen become positive charge. Total positive charge here, total charge here +1, only +1. Here total charge +1. So charges same or not? Same. So resonance is correct. This type of conjugative system, positive charge and lone pair conjugative system. Delocalization takes place in this way. And one more point, that is the last point, is stability of resonance form. Which resonance form is more stable? Stability of resonance forms. The resonance form in which negative charge present on more electronegative atom, more En atom is more electronegative atom is more stable. The resonance form in which more electronegative atom carrying negative charge is more stable. More electronegative atom carrying positive charge is less stable. the resonance form in which positive charge present on more electronegative atom is less stable. So see example here. Your negative charge is not present on both the structure, only positive charge. Here positive charge on carbon. Positive charge on carbon. Here positive charge on nitrogen. Positive charge on nitrogen. So which one is the more stable resonating form between these two? So this is less stable, definitely, because more electronegative atom carrying positive charge, less stable. Here less electronegative atom carrying positive charge, more stable, based on below points. So by remembering these all points, we can easily understand what is the resonance concept. And next concept, this is actually important for next concept. I have discussed, I explained here resonance for the purpose to understand mesomeric effect. Our topic mesomeric effect. To understand mesomeric effect, resonance is important. Resonance phenomenon is important. What is the resonance? Just delocalization of pi electrons and lone pair electrons in conjugative system is called as resonance. So resonance important to explain stability. So resonance is a different type, conjugated systems. What is the criteria for resonance? To occur resonance, to takes place resonance, there must be conjugative system. How many types of conjugative systems? There are 5 types of conjugative systems. They are pi, sigma, pi bond conjugation. Pi bond, sigma bond, pi bond conjugative systems. Pi bond, sigma bond, positive atom conjugative system. Pi bond, sigma bond, negative atom conjugative system. Pi bond, sigma bond, free radical conjugative system. Lone pair, sigma bond, positive charge conjugative system. In all those conjugative system, how delocalization takes place, we discussed. Whenever pi bond and pi bond are in conjugation, pi, sigma, pi, in which what happen? Non-polar pi bond move towards polar pi bond. When positive charge is sigma bond, negative charge in conjugation. Pi bond, sigma, positive charge in combination, pi bond move towards positive charge. When pi bond, sigma, negative charge in combination, negative charge move towards pi bond. When pi bond, sigma bond, free radical in conjugation, then pi bond homolytic bond cleavage takes place. When lone pair electron, sigma bond, positive charge in combination, lone pair electron move towards positive charge. What is the resonance energy? Resonance energy is the energy difference between least energetic canonical form, least energetic resonance form of the molecule and actual molecule. Okay, so as the energy gap is more, stability is more. Resonance energy is not direct energy, it's the energy difference. So resonance energy helpful to understand the stability of the molecule. Resonance energy calculated from the data of heat of hydrogenation and heat of formation. Okay, hope you understood. Take this one.